At 0400 hours UTC this morning, the Jet Propulsion Laboratory updated a file that most astronomers ignored. They shouldn't have. This is 2025 PN7. On paper, NASA calls it an Arjuna-class asteroid. They say it is a rock, roughly 19 meters wide, trapped in a temporary orbit around Earth. They are calling it a quasi-moon, a harmless companion that will follow us for the next 128 years. But if you look at the orbital parameters released yesterday, harmless is the wrong word. Natural asteroids tumble, they drift, they are chaotic. 2025 PN7 isn't tumbling. It is locked in a perfect one-to-one mean motion resonance with Earth. It isn't just orbiting the sun, it is stalking us, and the data suggests it might be watching. To understand why this is an anomaly, you have to understand the neighborhood. We are talking about the Arjuna population. These are rare near-Earth objects that have orbits almost identical to our own. Low eccentricity, low inclination. They are the shadows of Earth. We had one back in 2024, asteroid PT5. It stayed for a few months, performed a messy gravity turn, and got flung back out into space. That is normal behavior. But PN7 is different. It didn't just visit, it entered a horseshoe orbit. It is literally dancing with Earth, trading energy to stay perfectly positioned. It has a semi-major axis of 1.003 astronomical units. It takes exactly 365.8 days to orbit the Sun. That is not a coincidence. That is synchronization. Here is where the natural rock theory falls apart. It's called the Yarkovsky effect. When a small rock, especially one only 19 meters wide, spins in space, it absorbs sunlight. When it emits that heat, it creates a tiny thrust, like a rocket engine made of photons. Over time, this thrust pushes the asteroid off course. It makes the orbit decay or expand. For a rock this size, that drift should be measurable. But look at the data for PN7. The non-gravitational perturbations are 0. That implies one of two impossible things. 1. This rock is somehow immune to the pressure of sunlight. Or 2. It has an active stabilization system compensating for the drift. We have seen this signature before. In 1991, the object 1991 VG was discovered. It showed rapid brightness fluctuations, suggesting rotating metal plates, not rock. Astronomers admitted it looked like a spent rocket booster, but no rocket launch in history matched its trajectory. It passed Earth, scanned us, and vanished. Now, in 2026, PN7 arrives, but unlike the others, this one isn't passing through. The orbital simulation shows it will remain a quasi-satellite until the year 2083. If you wanted to monitor a civilization, you wouldn't land on the White House lawn. You would park in the driveway. It is sitting in the blind spot of our planetary defense grid. Close enough to intercept our radio leakage, far enough to look like a faint star to amateur telescopes. The James Webb Space Telescope is scheduled to look at this sector in 3 weeks. Until then, we are blind. Nature makes noise. Intelligence seeks stability. And right now, 2025 PN7 is the most stable thing in the sky. I will upload the trajectory update the moment the new data packets arrive. Subscribe and turn on notifications. You need to see the next update before they take it down.